We are now ready to start. Welcome to the free BIM orientation, where you will learn the meaning of BIM, how, what, where it can be used, and why it is currently considered a hot topic in the world of technology. The presentation will be held by myself, Naviswork, ETC's founder and director, Antonio Callas, who will teach you the basics of MEP. Given that most of you already know, or have previously worked, on architectural sites. A little overview of Mr. Callas. He was the one behind ABC Mall's Mechanical Engineering and King Faisal Academy's ACE company in Saudi Arabia. So not only is Mr. Callas an MEP instructor, he already has a deep-rooted portfolio in this profession. Another instructor in today's orientation will be Jihad Sphere, owner and manager of BIM International Production Company, consultant and officiator on some of the biggest projects in Lebanon and the MENA region. Lastly is Mike Charbel, who's a BIM infrastructure, civil 3D, and bridges instructor at ETC. Plus, he is a consultant for various operating companies in Saudi Arabia. In today's presentation, Mr. Charbel will illustrate, particularly for those of you who are civil engineers, how this technology operates. Before starting, and for more information regarding ETC and ways to contact us, typing basic keywords such as Revit Courses Lebanon or even Revit Lebanon onto the Google platform will help lead you right to us and our services. Our agenda for today includes us displaying our credentials, submitting a quick overview regarding BIM, creating a custom system in Revit by Mr. Antonio Callas, demonstrating an already built structure operated by Mr. Jihad, and overviewing the architectural Revit expounded by myself, where you will learn the definition of BIM, outlining the meaning and importance of both Civil 3D and Infraworks by Mr. Mike. And last of all, unveiling the tracks to become successful if you are interested in broadening your work and making use of BIM as a source for your future projects. To begin with, we as ETC are part of the Autodesk Training Center. Therefore, our certifications and diplomas are internationally recognized with prices that range between $100 and $150 in Lebanon, given the saddening current situation, which is quite beneficial for students looking to deepen their learning expertise, in comparison to New York, London, or Dubai, where the same diploma would cost around $1,000. ETC is also part of the Rhino Training Center and offers Rhino Diplomas, a tool well recognized among architects who practice freeform construction, such as the late Zaha Hadid. A few illustrations that showcase our previous productions would be of ABC Mall's full disciplinary model in Verdun, and the U.S. Embassy's architecture in Alcar, using advanced Revit modeling for a precise and thorough outcome. ETC's most well-known, $1 billion project benefited from our expertise in finalizing the project, as well as 10 of ETC's students, to help with the project's mechanical aspect. A quick outline of BIM. It is an object-oriented concept, meaning it focuses mostly on representing a specific asset. Simple examples of assets would be walls, doors, columns, stairs, ducts, panels, etc. It's 2D and 3D, and how they transform into extrude without the need for polyline, the formation of various sections, and how simple it can be to achieve the desired results. The usage of clash detections in BIM or Revit prevents the risk of crashing between two different assets, which will be shown in Revit. To help repair the design, before starting on the architectural site, showing the automatic creation of BOQ. All tools acquire the use of the same platform, which is Revit. There's a noticeable ease in the usage of communication and coordination between engineers. And lastly, the program is efficient, with minimal waste and accurate short project life cycles. Going more in depth now, Mr. Antonio Carlos will explain the definition of Revit MEP and its importance in this line of work.
Hello guys, today, I'm going to teach you the part related to MEP. First, and as you all know, MEP stands for mechanical, electrical, and plumbing. We are going to cover each of these today, in the orientation. Starting with an empty mechanical project. As you can all see, we will link the architectural file, provided to us by the architect, into our mechanical file, in the same way as used in AutoCAD. After linking the file, the architectural apartment shown in the video, we will start, as mentioned, by covering the mechanical part. Starting with the air terminals or the diffusers. Placing them on the ceiling provided by the architect. We will place the fan coil unit. And then we will draw the duct connecting the air terminal with the fan coil unit, adding the flexible connections, which in this case is the flexible pipe, connecting the diffusers to the duct. And finally adding the insulation. Here, as presented, is a typical example of an HVAC system. Let us start with the air terminals. The architect, as seen, has provided us with the ceiling plan. A 60 by 60 false ceiling. We will therefore be adding the air terminals accordingly. We are going to supply the flow by first adding the 60 by 60 supply diffusers, placing them at the exact same elevation as the height of the ceiling, as given by the architect. Thus, this is not only going to be about placing the diffusers, but also about creating the system. The flow shown here will be 200 liters per second per supply diffuser. And we will be placing 4 of them. It is very important to make sure that the 4 of them are well aligned. thus ensuring the organization of your project. You have to make sure your project is 100% correct, and Revit provides an easy route to do that. We now have all the 4 supply diffusers, well aligned and ready on the false ceiling. We are going to add 2 return diffusers, 400 liters per second each, in order for us to have the same airflow as that of the supply. We'll be moving to the part where we use the duct to connect the supply part of the unit to the supply diffusers that we have already placed. For example, we will now be drawing it, changing the size to whatever suits us, 500 by 300 mm for example. We will be drawing a duct, which is a very easy task when using Revit. As you can notice, that all you have to do is draw the run, and Revit will finish the work for you. Let's say here you need a tree branch. All you need to do is click on the plus sign, and you'll have it made. It's as easy as it sounds. We now have the duct in place. Let me fix it a bit upwards. Let us now switch to 3D view, and if you notice, the gray is the architectural model that we have loaded into our project, and you can see the ducts right here, with the diffusers under. Let us now change the visual style, so that we can see it in color. The 4 supply diffusers that were previously inserted are well viewed here, and the refill diffusers are shown here. Let us now connect each diffuser to the duct. To do that, all we have to do is click on the diffuser, click Connect Into, and Revit will connect them for you. You can easily notice now that the supply duct is supplying air from the unit into the diffusers. An important thing to remember is to make sure to add a cap at the end of all ducts, as shown here, to have a finished, well-ready system that can supply air from the unit to the diffuser. Having finished the duct part, we will now be moving on to adding the flexibles. To do that, we have to convert the connections to flexible connections, as seen here. This is an easy task to complete, which results in obtaining more flexible connections. Moving on to the placement of the insulation. Having both external and internal insulation. Adding external insulation first. We will begin by selecting the system that we just created, removing the air terminals from the system, and insulating the duct. To do that, we will be insulating the shown selection, adding the insulation option as shown, and also specifying the type, as well as the thickness of the insulation. By finishing this step, we would have the requested results of the external insulation. Arriving at the final part of this, which is adding the internal insulation, we will insert internal insulation on the first 2 pieces. We will then add lining, and specify both the size and the thickness, in order to create the desired internal insulation, which will only be shown when clicking on it. All is done with the mechanical part of the explanation. Now, we will be moving to the plumbing part. By plumbing, we mean domestic cold water, domestic hot water, and sanitary. We will first add the plumbing fixtures. Take them from the architect, and you will learn how to do that. Then draw the sanitary pipes, and then the domestic cold and hot water pipes. Let us first copy the plumbing pictures from the architect. As you can see, there is a clear division of various categories on the left side of the browsing project. As you can notice, while accessing one plumbing, when zooming in, you can clearly see the WC area given by the architect, with the lavatory and the water closet. In order to copy them, all we have to do is copy from the architect, copy from the link that we already used. Choose a picture to copy, and give it a bit of time to finish processing. When clicking on the water closet, we can see that it has two connectors, one sanitary connector, and one cold water connector. The lavatory, on the other hand, holds three connectors: the domestic cold water, the hot water, and the sanitary. We will first start by creating the cold and hot water pipes, and then we will create the sanitary pipes. The creation of the hot and cold water pipes is an easy task. First, we are going to click here, and before beginning to draw, we are going to select the pipe type that we will be using, which is the PPR pipe. An important thing to notice is that our aim is not simply to select a pipe, but to also be specific in choosing which type of pipe we want to use. Next, we should specify the system type, and by clicking on this pipe, we will make sure that the pipe we are using is a hot water pipe, the PPR pipe, with a 25 cm diameter. Drawing the second pipe beside it, we will now be changing the elevation of the pipes, in order for them to be able to be drawn vertically and reach the roof, no longer at our level of sight. As you can see, the red pipe is for the hot water, and the blue one is for the cold water. You can therefore modify the colors as you choose, in order to have a clear, organized prospect. Switching to the 3D plumbing, you can now see what we have created, with vertically positioned pipes that reach the roof, ready to be connected to the tanks. The next thing is the creation of sanitary pipes, connecting both the lavatory and the water closet. This is a very easy step, that first includes the drawing of a section. We specify the extent. We then go to View, to make sure that the retail level is fine, and then we will be able to see the lavatory from the side. When clicking on the lavatory, we can see the cold and hot water pipes that we drew earlier, and right here, as shown, is where we will draw the sanitary pipe. Then we click Switch to PVC pipe. Make sure that the system type is under sanitary. Draw a pipe and lead it underground. Then we have to add slopes, not manually, but we have to select slope down 1%, as shown, and then we can notice that while drawing in a straight manner, Revit will take your pipe and add a 1% slope down to it. And there we have it. When we switch back to plumbing, we realize that the underground pipe is not visible. That is, because the underground is below our current level, we cannot see all that is underneath. To be able to do that, we are going to add depth to our range, as shown, so the pipe will become visible to us. We are drawing another pipe at a 45-degree angle, and we will lead it outside of the building. As can be seen, the 1% slope is also visible here. The size of the main pipe to 100. We are going to now be connecting the water closet to this pipe. Having finished both the lavatory connectors and the slopes, we are now going to switch to creating the pipe related to the water closet. First, we need to move the section as shown. Then open the section again. Now, we can clearly see the water closet. After clicking on it, we draw the pipe downward, and slope down 1%, in order to attain the resultant pipe. After drawing this pipe, we will make sure, as shown, to draw a 45-degree angle on here, without having to measure each angle individually, seeing as they are implemented. Since both pipes are sloped, it is a bit tricky, but easy, to connect them. So, what we will do, is make sure they are visually aligned, and connect them only after that, so that they are well connected, and then we will delete the section, and go to 3D, in order to properly observe what we have created. We can now see the 3D version of the sanitary connectors that the plumber uses in order to finish the work. And here, we can even switch to a realistic design. Now, as you can see, we have a connection from the lavatory, the water closet, to the outside of the building, with a 1% downward slope for coordination purposes, a very important feature that prevents clashes. Moving on to the electrical part of the presentation. We will be working on adding lighting fixtures on the false ceiling, near the diffuser. We will be adding the panel board that will be used to connect the lighting fixtures to it, and provide power to the lighting fixtures. We will be learning how to create the circuit that connects these lighting fixtures to the panel board, and then, we will be learning how to create conduits and cable trays. Let's begin with the lighting fixtures. As you can see, we have a view related to lighting fixtures on the ceiling electrical. We have to always make sure to show the diffusers in the mechanical part, because we have to put the lighting fixtures in a way that prevents them from clashing with the diffusers. To place the lighting fixtures, we first click on the lighting fixtures as shown. Select the 60 by 120 lamp, place it on the face, and have Revit read it on its own. We will now be placing the 4 lighting fixtures exactly centered as demonstrated. Perfectly aligned with the diffusers. We will now be adding the panel, and give instructions to Revit that the 4 lighting fixtures will be taking their power from this panel board. Selecting electrical equipment, we will be using this type of panel board, and placing it in this electrical room. What we do now, is create a system for the 4 lighting fixtures, so Revit would be aware that all 4 are under one power system, connecting them all together. We then specify the panel that is responsible for providing the power, as shown, so it becomes included in the system. Now that the system is ready, we have to show the wires connecting all of them together. We click on the arc wire, then click on each wire on its own, and the symbol shown represent hot, neutral, and ground conductors, and we are able to modify each symbol, as shown here. We will now be moving on to creating conduits. Seeing as we already inserted a panel here, we will be using it to create conduits from its side, for example. The first thing we're going to do is right-click, and select Draw Conduit. Showing you only one side of the panel, Revit will then ask you to provide the location of the conduit, taken from the side. We will now be choosing the upper left corner, and clicking on Finish. The conduit is not visible here. That is, because this is from the electrical lighting fixtures view. Switching to Power View, we will now be clicking on the panel board, drawing conduit from face, and again specifying that the conduit would be in the upper left corner, selecting Finish, and changing the size of the conduit now that it is clearly seen. Draw a conduit and then move upwards to the false ceiling. To do that, we need to change the elevation, and Revit will, after that, do the rest. The same process applies when drawing another conduit, even if your choice was to draw one that is near the first, as it is shown here. When observed from 3D, this is what the design would look like. As you can see here, we picked the upper side to draw the conduits, so we have all this space to draw as many conduits as we want. Moving on to cable trays, the last electrical part. In order to attain the desired results, We first click on cable tray, and as we have different types of cable trays to choose from, we will be selecting the ladder cable tray, and specifying afterwards both the width and the height. You can choose whatever numbers you want, and then we will be drawing, while leaving the detailed fittings to Revit. And also, by clicking on the plus sign here, we can have the T for the cable tray, as demonstrated. Now, showing the cable tray, as you can see, it is quite easy to attain the needed results using Revit. Now that we have finished the explanation, and therefore covered all the necessary models, it is important to know how this teaching project will benefit you. We will now, therefore, take a look at another project. A bigger project that still shows you everything. When zooming in, you can clearly see, taking this room as an example, the lighting fixtures, the diffusers, the sprinklers, and the WC area are connected, as can be seen with the sanitary pipes and the cold and hot water connectors. On the roof, we can also see the tanks, the hot water tanks, and the pipes for the fire system. Everything is well organized, and split into categories in the project browser, and displayed accordingly. The benefits of this are bulk quantity. We can therefore easily count the quantity of the air terminals with full precision, using Revit. By clicking on Schedule, and then clicking on Show the precise number of diffusers, as we can now see a list of all the diffusers available in this project. Grouping the diffusers according to similarity, we will then be shown a list, containing the total number of diffusers without struggle, even automatically updated within the system, if you choose to either add or delete a diffuser. And it can thus be found inside your project, as shown. Another benefit to this, is clash detection. Learning how Revit can show you what items are clashing through a well-presented and thorough report. Zooming in and moving one of the lighting fixtures in such a way that it becomes an obstacle, and clatters with the diffuser. So now, when creating a report for his project, checking the air terminal versus the lighting fixtures, Revit should inform us of the clash that the two are experiencing. by creating an interference check report, as seen here, and choosing air terminal versus lighting fixtures. Of course, this is only an example. You can always pick different categories to choose from, and then you will receive a report that showcases the clash of the two, which will also be highlighted for you to see. You can also click on View, if the items are not currently shown, and Revit will take you to the exact view and show you. After fixing the clashed items, you are not obliged to make a whole new report. You can simply click on Refresh, and Revit will either showcase the newly modified report, or a blank page for no detection of interference. When trying to experiment with reviewing the report, a No Interference Detected pop-up notification will show. To inform you of the absent clashes in your project. Another benefit is the pressure loss report, a report that is needed for duct or pipe systems. When creating the pressure loss report for ducts, we click on Duct Pressure Loss Report, select the chosen system. And then click on the categories that are to be shown in the report. Click on Generate, and then type the file name, which is Duct Pressure Loss Report, and then receive this. Different sections for different categories are shown, such as the flow, the size, the velocity, the length, etc. One important part in this is the critical path. It is something widely used to calculate the static pressure for the system. You have to therefore select the unit according to the total pressure loss needed, shown in the report. The already mentioned points are the main benefits that Revit can provide us with after finishing a project. If you have any questions concerning the matter, I am willing to provide you with an answer.
We have now seen the advantages of BIM MEP. We will discuss BIM in greater detail later. Mr. Jihad will now show you a few of his worked on BIM projects and what he delivers to his clients.
Hello guys. Today I am going to display a few of the end results of my work. But we are also going to learn how we got that result and what we did to obtain it. To begin with, and as an experienced engineer wanting to design a manhole with thoroughly detailed iron techniques in order to properly design a building, as seen, with an opening and a shaft opening. How we managed to merge the seam iron. If this same design was formed in AutoCAD, it would not have been possible to understand where each iron was located, thus wasting time, manpower, and tools that would not be needed on execution day. Our job is to ensure that this work is properly accomplished, and Revit helps in ensuring that all is done accordingly, from iron professional placement, to opening reinforcements, and most importantly, having a correct and well-made bar bending schedule, that helps the blacksmith operate in an efficient and thorough way, with minimal time, and slightest iron waste. This work is, clearly, divided into various levels. Somewhere we operate in 2D, which is quite necessary in Revit, as shown here. We have a manhole plan and determined, therefore, that this opening that is based on the said code has to have 2 rebars of 900 centimeters each, for it to be suitable. We therefore plan, and based on the planning, we move to the execution. The planning is divided into various sections, and each section is thoroughly designed and detailed. AutoCAD can evidently be used to design the plans for the manhole, but it is not fundamental to use it. The design can therefore be finalized without the use of AutoCAD, but it can be an option if it's already accessible, and can benefit us by forging ahead and completing said 2D element. What we are now seeing here is a 2D-3D merge, where we clarify, in detail, the entirety of iron, its size, and how the iron is going to be distributed later. We were able to easily design the shown bars, based on this information, and the opening detail that we had already designed, according to its specific measuring. It is important to know that, in a structure, views are vital. Each section ought to have its own floor plan, and its own annotations, meaning detailed remarks concerning each selection that help organize the planning. In order to properly execute the work, for better and faster execution, everything is thoroughly clarified in the map. Moving on to the elevations. As is exhibited here, the iron is already designed, but what we did is modify it, and also modify how we see it, and what parts can be perceived through Revit. The 3D planning process must be well designed, and systematic, so that our mapping is easy to understand and apply in real life. Another thing to focus on is to make sure to keep the company's style in the mapping. Each company possesses its own style in presenting the work it designs. One might use rebar following this system, for example, so the people dealing with the plan would know what everything translates to. You can see it here, with the letters A, B, C, D, E, representing iron. And also, here are the shapes that are depicted. If we are not able to get to this level yet, we need to therefore have more practice to be able to reach this stage. Hence, this is the manhole, and using Revit, we can work on deducting as much as we want from it, and once accessing the books section, an exquisite section that is, that permits us to access the 3D model from anywhere, and lets us thus perceive whichever accessible section, and even correct the model. According to the schedule, by going to the schedule, clicking on the element that might not be designed correctly, and then selecting Highlight Model, in order to inspect and make sure that the work is precise. Therefore, anytime there's doubt about not having the work to be well completed or 100% systematically achieved, we can use this method to double-check our work. Seeing as the model is connected to the schedule. BIM, thus, is the software that connects all the pieces, so that it helps us deliver a well-designed, perfectly planned map. It is therefore not a company name BIM, but a way of working that depicts very detailed results. This applies to everything used in Revit, whether it be mechanical, architectural, or something else. Let us now plot a minor construction, so we can further understand how iron works in Revit, in a simple, yet efficient way. We need to first open a new file, as Mr. Antonio stated earlier, and place the grids. We are going to design a simple structure that portrays the grids in any direction we see to be suitable, and then number them in a way that aids us. Unable to previously share the screen, the structure is now seen on the screen, and as we can notice, we have a floor plan, a 3D view, an elevation, a section, drafting views, etc. Let us begin by saying that, like any structured model, we usually have grids and structural columns, in which we can choose which structural column we want to use, with a size that can be unfinalized, meaning we can choose to alter it later on. You can now notice that everything that I am placing in 2D is hereby being put in 3D. The structure is very easy to use as a way of designing, whether in 2D or 3D modeling, which is easier than architecture, being strictly limited to columns, beams, or footings. We have now placed the 4 columns, as you can see, and now we will move on to designing a footing for those columns. Revit is designed, and therefore already contains various detailed categories that help ensure we reach our aimed goal in the work that we are doing. Once we select insulated footings, Revit will then allow us to place them either at structural columns, or at grid intersections. We will then select the whole column, and there, we will obtain the requested footing. The same result is obtained with the same timing for an infinite number of columns, unless we change the footing size, in which case, we need to alter the process. We are now going to move to the ground floor, and we have this already, because we prepared it in the elevation, to be composed of a ground floor, top of footing, and a first floor. When selecting the ground floor, it is important to notice how each column is understood and measured by Revit, thus helping us with where each column should be placed, and therefore, if the work we are executing is correct. Moving on to the structural floor. We will now design with the columns, and notice how Revit quickly forms the slab we are trying to draw. And there you have it. This is the slab. We can either edit it in 3D view, or in 2D view, and even control it, whichever way we want. We are, therefore, able to observe the design, from whichever point we want. We will now move to the first floor framing, in order to design its slab. Revit resembles AutoCAD in this regard, so we can benefit from the various options that can help us, such as copy to clipboard, align to selected level, etc. This applies to floors, columns, beams, and almost everything else in Revit. The building is now complete, so now if we want to move to the iron part, we need to start forming what we will be working on. Thus, if our aim is to display the sections, which is a very important part to do, we need to structure, meaning we need to click and drag, in order to automatically form the wanted section. We now specify its scale. Whichever scale we need, we stretch, and work with it, depending on what we want. For iron placement, it is good to understand that framing is considered an easy task when we design and place the columns in the right place. Before we move to framing, let us place the beams first. We can design them by choosing the specific type that we want, in order to properly draw them, and, of course, We can easily choose to change their size whenever we desire, without it affecting our work. Returning to the framing section, we must now design the iron, using the tools provided by Revit. For example, by clicking on the structure, as shown, we can see the various tools provided by Revit. In order to start, I personally always abide by the principle that when beginning as a new user, ask so you can receive an answer. So, by selecting a specific element as seen here, Revit will guide us in what to do, meaning that it will tell us that this specific element is a beam, so we can use rebar, for example. After selecting the slab, Revit will give us notice that we should either use rebar, area reinforcement, or various other options. We will learn in a bit why each selection is met with different options. Now that we have successfully created a section, let us start with the area reinforcement. Since we aim to show something specific on each floor, I have already prepared the views. Some relate to the framing, and others to the reinforcement, since we already have the views. The same principle applies here, where we select and choose which option to click on. Selecting area reinforcement first means that wherever we design, Revit will automatically place a reinforcement, which simplifies our work. It is very important to notice that in the Property section, Revit details the iron placement. With its systematic measurements, and with the option of modifying whatever needs changing, we are therefore programming the iron placement, which is considered a very important factor in finishing a completed design. We can now see the iron, and how it's placed. We can, of course, choose different views to look at as shown, and make sure, therefore, that the iron is well placed, and perfectly aligned. If the column doesn't have the option of us being able to choose an area of reinforcement, we need to choose rebar. Notice how we have the option of using area reinforcement on the floor and the wall, but not with the column. If we now decide to place iron in this element, we click on the rebar as illustrated, and a new pop-up window will appear, either on the right, or on the left of the screen, with various iron options to choose from. As we can notice, we have various default rebars to choose from. And by clicking on this one in order to design a new one, using Revit's tools as demonstrated here, with explanation pop-ups that help clarify the ways to do it. So, these tools help us visualize what we want our work to be. We can now see how it is done. And now, by clicking on the space bar, we can easily place the stirrups. changing the shape, and choosing a single line-shaped rebar. Programming it. Thus choosing a fixed number, and choosing 3 to continue the work. We can, therefore, choose where to place the rebar, and this plays a part in the end result, and in what and how Revit spreads the rebar. We can also, to emphasize, make use of all the tools that resemble those found in AutoCAD, in order to help enhance our work. Selecting a specific element in 2D, and having it highlighted in 3D, will help us revisit our work, and double-check its accuracy. Selecting the iron is a very important task to complete in Revit. In order to specify whether we want it to be viewed in 2D or in 3D, especially when talking about a big project, where there is a great amount of existing iron. By default, Revit inserts one element, and then we can choose to act on this element, thus deciding how to manage it. Once the already made iron is well placed, and fairly distributed, we can now copy it, and transport it to various other sections, without having to redesign from the first step. The same concept is used in designing columns, and the view can be seen in 2D, as well as in 3D, for better coordination, as shown here. To emphasize, the rebar schedule is automatically created, without the need to recreate it with each new step. Let me conclude by saying that there are so many details in this, but as an introduction, it is important to know that iron designing in Revit is a very important task, and creating it can thus be easily attained once we learn the proper usage of the provided tools.
This part of the orientation was given by Mr. Jihad, who excels in the work he does, and therefore, operates many projects for various, quite important companies, that in turn trust in his decision-making process and thorough project delivery. We will now begin with another part of the orientation. Seeing as most of you have already understood what BIM is, let us now initiate with a presentation that deepens your understanding in that area, and further expands the definition of what the concept of BIM signifies, and how it is a concept, rather than a piece of software. I will now begin to strategize a building floor, so you can see how this will apply in architecture. Which, ordinarily, you will not need, but this is so I can fasten the process of design, instead of designing a whole floor from scratch right now. Clicking on South in the elevation section in Views, we can see both the ground and the roof, at 3 meters. Clicking on the wall, thus wanting to design a 200 mm generic wall that reaches the roof, with a core face exterior location line, and then clicking on the chain. We will now design the wall, drawing it without stopping, with the same concept as if we were designing it using AutoCAD, not even stopping on walls nor doors, as if they did not exist. Each window will then automatically create its own opening. We have now finished creating the exterior walls, fastening up the process, seeing as this is only a presentation, and not a course. Moving on to designing the interior walls, we will be choosing the generic 100 wall, with a core face exterior location line that reaches the roof, and also clicking on chain. Next, as seen, we will place the walls accordingly. In order to thicken the wall that we have just created, we will select it by clicking on Modify and choosing the generic 200 in the library. We will now continue by selecting Architecture and then on Wall, choosing generic 100 and creating the needed walls by clicking on the Escape button and then on the spacebar. The Escape button, pressing it twice after that, pressing the spacebar, almost done after that, creating walls here as well, clicking on the spacebar and Escape buttons when necessary. Now that the design is finished, we can now clearly see it in 2D and 3D. Given that we do not have a floor yet, we will click on the ground in the Floor Plans section of Views, and then click on Floor, Floor Structural, and choose Generic 300 after that. Instead of designing it, we will click on Pick a Wall, as shown, click on the chosen tab, and then click on Finish, in order to obtain the floor displayed here. Seeing as there has been an error in this wall, we will rectify it. By using the Align button, your future favorite tool, in order to attain this finished, well-made design. Let us place windows. Without going into too much detail and specific sizes, this one, as seen, is good for the entrance. This one can be used for the bedroom area. The wall, when clicking on it, will automatically make an opening, while clicking the spacebar will reverse the action. By choosing a smaller window that can be used for a WC now, like this one, by clicking on the spacebar. Placing an architecture window, a small bathroom window, choosing another bathroom window, and inserting it here and here, as shown, removing the tag. Let us now add a kitchen window. We now need to add the garage doors, and in order to do that, we will click on Architecture and then on Door, and click on this door, as displayed. Here, the whole floor is presented in 3D. Adding the furniture now, we will click on the ground, on a component, and then on Place a Component. Place the furniture in the dining room, and a few sofas in the living room. Let us now add a camera in order to have a better view, and seeing as my height is 190 centimeters, I will be inserting that in the offset option, thus bettering my view in 3D, as seen here, and can also be perceived in color. By renaming my 3D view as living room, we will now learn how Revit determines where a clash took place. We will now place a column where it does not belong. We will thus click on column, then structural column, and choose it to be designed vertically, reaching the roof. As planned, we are now going to place the column here in an unsuitable place. Given that the clash that can be well perceived in Revit has been previously explained in this orientation by my colleagues, let us now perceive this misplaced column. It is very easy to spot the column in this simple building, but let us imagine a mall or a hospital building with various columns and different sections that make it hard for us to spot a mistake. That's when Revit aids us. Let us now click on Collaborate and let an interference check run next by selecting structural columns, walls, and windows to get the needed results. This error can simply be rectified by erasing the misplaced column, whereas, if the same error reaches the workshop, major problems can take place, whether with the design or not being able to deliver on the due date. Let us now form a section really quickly. We will select a 2D section as seen, right-clicking and then clicking on Go to View to attain the wanted section. We can also choose to view our design in fine detail as shown, and seeing as we did not go into detail with the walls, we can, at any time, change them by clicking on one wall, selecting all instances, and then on the entire project, and choosing another, more detailed wall, as shown. And we can even choose to change the floor. We will be changing it to become a wooden floor. When looking closely, we can see the layering, that of the insulation and the finishing. Our floor is now considerably detailed, given that we have obtained the section's results in no time. Say now we wanted to count all the doors existing on this floor. We therefore click on View, then on Schedule Quantities, and from the list that shows up, we select Doors. And then select all the information that we are requesting to know. The door schedule can now be seen, and we can even select to view it in 3D, showing both the floor with its door schedule and the door schedule for better insight. We can also select various sections from the schedule for them to be selected on the floor, and even change and modify the different doors right from the schedule to have them changed on the floor. We can thus rectify the doors from both the schedule and the floor, causing them to be automatically modified on both sides. What is BIM? BIM stands for Building Information Modeling. It is a concept, and therefore it is neither a software name nor a company name. AutoCAD is not BIM, whereas Revit is BIM. Everything is, therefore, connected. Moving on now to show you some major projects, such as this medical building for USJ, that we have worked on its architectural building. Usually, once the architectural side is completed, the mechanical engineer moves to work on his part, which shows how complicated it can be. This type of work is highly demanded in the workplace now, so it is quite important to know how to learn and excel in it. As a result, Revit is now much more in demand than AutoCAD as a work-based concept. Now that I have covered all the various topics in my presentation and discussed USJ's medical building, we will now be moving to the questions. If someone has any, please do ask.
What might be the unsolvable problems facing the architects that require them to transport the project to ETC?
Architects and engineers often design their plans using AutoCAD. Our job is therefore to rejoin these different mappings in a way that coordinates them and perfects the wanted job, fixing the mistakes that would not show unless they were all connected, thus helping deliver a thorough plan to the workshop that results in minimal slip-ups.
Would the requested job be to link various engineers and architects' plans into one final modified map?
Yes, absolutely. For faster results, that is.
Can concert podiums be designed using Revit?
For now, all that had been tried on Revit had resulted in being a successful map, from small projects to immense ones, such as the American Embassy, which was well presented through Revit's futuristic designs. Therefore, Revit is considered a very powerful concept, needing a bit of time to acquire practice in order for its users to be considered well-skilled and able to handle a well-rounded project. Moving on now to Mr. Mike Charbel. who will teach us about civil 3D and infrastructure, stressing the fact that very few people recognize their importance and know how to make use of them.
Hello guys. My name is Mike Charbel, etc.'s Civil 3D and Infrastructure Professor, and I have more than 10 years of experience in engineering, design, shot drawing, planning, and management. Today, we'll go over 3 critical points, which are: what kinds of projects can we use infrastructure in, what we need to use infrastructure in using BIM software, and how to achieve the desired results. We have already used these techniques to work on many projects, like King Abdulaziz's International Airport, King Abdulaziz's route in Saudi Arabia, Jabal Almer Village, and a few Arizona projects. I recently worked as an MEP coordinator, a UK company consultant, an African multi-billion company's business development manager, and a manager for a company in Lebanon. Starting the presentation with the first point to broaden, which is, what kind of projects can the infrastructure method be used on? To which the answer is roads and highways, road rehabilitation, and civil structures collaborating with Civil 3D. It can also be used on airports and on rails, where we can either redesign already existing rails or plan a new rail design. Moving to the land and water section, we have various other options to work on as projects, such as developing a site by improving its pipe networks using Civil 3D and infrastructure, ground force, and pressure pipes. We also have water and pipe projects that can be completed through this method. Let us now take a look at some projects, and then explain how Civil 3D and infrastructure work. This here is an infrastructure project. A small part of the Arizona project, where we designed a map for all the infrastructure utilities and services. On the other hand, this is part of King Abdulaziz's airport in Jeddah, where we are looking at the services profiles that have been worked on, which are the PCA tax, and many other services. This is shown here at the airport, where all the underground networks were designed. What we are seeing now is King Abdulaziz Road, a huge project in Saudi Arabia. Here, we are checking all the detailed underground networks, from manholes to handholes, the firefighting wastewater, the rainwater, the treated sewage network, and the underground telecom. All this has been designed in Civil 3D, emphasizing therefore the project scale that can be planned in Civil 3D. Here are all the underground networks, the collectors, the pipes, and the telecom that run below ground, through ducts. Let us now explain how we can design our projects using Civil 3D. Here, for example, we have a California Oceanside project, where if we want to design an alignment on its road, we are now able to have alignments that comply with the international standards. To make an alignment as shown here, in a civil 3D polyline road, click on Design Criteria, select Use Design Criteria file afterwards, in order to make sure the road is compliant with OSHA standards. You can, of course, choose whichever standard suits you best, and then click on OK. As seen, we have a violation of the selected standards. Here, we can either choose to change the road's alignment style, or simply change the road's design criteria, which we did, to 80 km per hour, as shown. This is, to emphasize, a very important feature in Civil 3D, which ensures compliance with the international regulations. Civil 3D is a very broad concept, having the options of not only designing profiles, but also surface, alignment, and profiles, and then moving on to designing road sections. We can, in Civil 3D as well, design a service profile, pipe networks, corridors, and intersections. Let us now explore how a profile is made. Based on the alignment shown, we will thereafter add an existing site, in order to obtain the wanted profile. Changing a small detail in the alignment, will automatically result in changes in the profile, the surface, and all the available sections, and that feature is what makes Civil 3D, part of the BIM concept. At this point, as shown, we can perceive any desired surface, and can therefore design an underground pipe, for example. Another thing to add, is that we can, in Civil 3D, divide parcels. And saying we wanted to split an estate, we will take this residential block shown here. Click on Parcel Creation Tools, and then add a few criteria, such as wanting each division to be of 900 meters with a 20,000 meter minimum frontage. Choosing an offset, and writing down all the other wanted criteria. Choosing the wanted parcel to divide, and selecting the frontage, as seen here, and noticing now, that Civil 3D divided the parcels. We can also choose to enhance the limits found between each parcel. We can easily obtain that, using spring lines in Civil 3D, which can also be used to find solutions for border demarcation, as well as other issues that various countries might face. Let us now talk about corridors. It is important to know that when forming road corridors, we need to make an assembly first, whether for a small road, a highway, or a subsidiary road, prepare the lanes, the shoulder, the slopes, and then form the wanted corridors afterward. This corridor that I am now showing you is a result of these assemblies. By clicking on Option Viewer for a more thorough view, we can now see the already prepared assemblies, and how they helped form this corridor. Changing the visual style to shaded, we can notice how this option is doable, using Civil 3D. One other option we can work with using Civil 3D, is the pipe network, which we are observing now as a storm network. We will now perceive a few elements, so that the view will be more sufficient, observing the structures that can also be placed in Civil 3D, and getting each element's data sheet, no matter its type, to be doable in Civil 3D. Perceiving the elements using an object viewer now. We are now inspecting the toolspace, and how we can find everything here, from alignments, parcels, surfaces, the option to design a new surface, the pipe networks, and storm networks that we discussed earlier, with their pipes and structures. All that exists in the file, therefore, can be found in the toolspace bar, with each having their own settings. Moreover, it is significant to notice how Civil 3D resembles AutoCAD in its drawing area, and Revit in its project. Another vital option in Civil 3D is that we can form a sample line, and various sections, as I will do with a 25-meter distance between each. By clicking on Section Views, creating multiple views, and choosing my road alignment with this sample line that I designed to be right above it, then clicking next on Creating Section Views, we can now perceive this sample line's multiple sections. Another thing we can do in Civil 3D is form quantities. By clicking on Add Tables, we can either form a schedule for the structures, or for the pipes. Choosing the wanted network. We now have obtained the table that used to be difficult to get before 2009, when using land development, where all the work had to be manually done. On another note, and moving on to Infraworks now, which is a more conceptual part of the infrastructure, and can be used by using diverse maps, designing roads that already have their assemblies, joining together multiple roads, and site designing the map as shown. I will therefore be choosing this part, and designing a small site. From a building's conceptual design, we can also choose to design a graphic simulation, mobility simulation, placing drainage networks, bridges, city furniture, and various other things. choosing a light pole. For example, I will be placing it on the road as shown.
After being done with the presentation, it is important to stress two vital pieces of information. Seeing as we are part of this advanced world, and its rapidly tools, that might someday suppress a university degree, taking a quick look on our website, you can easily access the roadmaps section. If, as an engineer, your aim is to know how to become an expert in architectural BIM. There, you will find various suggested courses to help you achieve your purpose. The same thing applies to structural engineering, where you can access it by clicking on its own division and taking a look at the many available recommended courses that you can make use of. The same idea applies to mechanical engineers, infrastructure design experts, and all the other opted divisions available to guide you on ETC's website, as shown. Moreover, you can easily, as a student wanting to assess your work, access the online exams option for free. Click on Take in whichever course you want to check your familiarity with, and choose up to 118 questions that require 135 minutes to solve. You can also click on Clear All, select the interface option, enter your name, email, and the required information. And once the exam is finished, you will automatically receive your grade. You can retake the test as many times as you want, free of charge, if you need to reassess your level in a certain course. We, at ETC, want to thank you for giving us the time and bearing with us, given the load of information that was shared today, and we will now be moving to answering any questions you might have for us in the next 10 minutes.
What is the exact process that takes place, other than the free online exam, in order for someone to register at ETC?
The process is very easy, and it would be best to contact us as ETC, having already the phone number, WhatsApp option, and the 1 month in advance prepared online schedule on the website, benefiting from having the first 2 hours for free. A beneficiary can, therefore, explore their options before even choosing what course to take, and paying for a course they would not enjoy or need. Because of Lebanon's unfortunate events, these courses have become way cheaper to enroll in, when compared to both Lebanese courses before the economic crisis, and courses taken outside of Lebanon.
How many hours would each course require?
Approximately 24 to 30 hours for each course, taking around 1 month on average to complete, divided into 4 hours per week. There are also some intensive courses that take around 1 week to complete, acquiring students to take around 4 hours daily, in groups, giving, in all taken courses, all the required information in a gradual method that helps the students grasp the information easily, continually helping each of you learn from the errors that might take place if you happen to find yourself trapped in a part with no explicable solution that prevents you from finishing your designs. Online courses have been found to be more efficient than interactive sessions that help the students achieve their targets more easily, with the aid of their professor. If you want to search for courses that interest you on our website, you can do so easily by clicking on the schedule, then selecting the desired course, and finally clicking on search to find the desired result. Many courses will then pop up, with different dates and times, split by categories, with the option of screening through the table of content in each course. You can even access the website, join or place your name on a course's waiting list, filling out all the needed material for us to later contact you with detailed course information. Another option is to simply contact us by WhatsApp, or by dialing the provided numbers in the contact option.
I'm curious to know, how can these courses benefit and strengthen me as an electrical engineer?
One should first take the Revit 1 course, a common course that benefits all, and then register for Revit MEP, where you learn how to design and place lighting, panels, and conduits, and how to join them together.
I'm an industrial engineer, wanting to ask if Revit could be used to develop machines that help with iron?
No. Revit is a building design. Another applicable software for industrial engineers that helps with machine design is called SolidWorks, and it is best suited for this kind of work. Revit MEP, however, can be studied if one wishes to find work in the construction building part, as many choose to do later on in their career.
How can we know the prerequisites for each course?
The most important course to register for is Revit 1, and clicking on the wanted course will give you additional information specifying which courses are important to take as prerequisites, as shown here.
In electrical engineering, which software is more suitable for designing the circuit board?
The circuit board in itself cannot be attainable using Revit. It can only reach a point where you can get the panel board, in a way that distributes all the parts accordingly. It is important to emphasize, therefore, that Revit is not considered an electronic design. Seeing as there are no more questions, we will now be ending the meeting, in hopes that ETC's team was able to assist you today, and help guide you, for the future.